Alright guys, so I'm going to go through both of these showing you how to make these solutions. So for the first problem, I tell you you have a solid and you're making a solution. So based on that, you know that you're going to have to use your molarity formula. So I know, let's just review, that molarity equals moles of your solute divided by liters of your solution. So for here, I know my concentration, it's 2.0. I'm solving for moles. My volume needs to be in liters, and right now it's in milliliters. So I'm going to just do this in my head. I'm fine with you doing it in your head if you can do it. If not, actually show your conversion. But I'm going to just move my decimal place over 3 places. 1, 2, 3. So this is going to be 0.25. Okay. So the moles that I end up getting would be 0.5 moles. Is that what people got?
Yeah.
Okay. If you put that as your answer, it would be wrong. Why can you not put 0.5 moles? Celia?
Because you can't measure moles in the lab.
Exactly. You can't measure moles in the lab. You've got to convert this into grams. So I'm going to do that by using the molar mass. So I have moles on bottom, grams up top. The molar mass of sodium hydroxide, what did you guys get? 39.97. There you go. That's fine. So when you do this and round to the correct number of significant figures, which for this problem you've got 2 and 2 here, it should be 20 grams. Is that what you guys got? All right, so let's talk about steps because the steps seem to be what are stressing people out. Is that a hand or are you? You need the point because that makes it 2 sig figs versus just 1. All right, so my first step, I'm going to measure 20 grams of sodium hydroxide using what? How do you find the mass?
Scale.
Good, using a scale. Then I'm going to need to add that solid to a container. Now the final volume that I want is 250 milliliters, so I've got to figure out what container to use. What is the best container to ever use? Volumetric flask or graduated cylinder? I want a volumetric flask. So let's see, do I have, it has to be exactly 250 mils, okay? And if you look, I have a 250 mil volumetric flask. So what I'm going to do is I'm going to add the solid to this, and then I will add enough water to get a final volume of 250. Okay. If instead I had said 150 and I don't have a 150 here, then what would I have added it to? My graduated cylinder, right? So measure 20 grams of NaOH using a scale, add to a 250 mil volumetric flask, and then you need to add enough water to get a final volume of 250 mils. And I'm done. Are we okay with that? Any questions? Why am I being so OCD about this? And I'm being really OCD. Why? Not just to be a pain in your side, I promise. There's a reason. Gentlemen.
Because we're eventually going to do this in the lab.
You're going to do this on Thursday. You're making solutions and doing a lab. I'm saying, here you go. Here's your silver nitrate. Here you go. And you have to make your solution in order to do the reaction, in order to get your results. And if you do it incorrectly, your percent error will be very high. Okay, so you've got to be really careful and make sure that you are really using these steps. Yeah?
So what happens if you mess up, like in the actual lab?
If you're doing this lab, right, and you measure 20 grams, and then you're adding water, right? You're adding water to your volumetric flask, and you are supposed to add water until you hit this line, right? And you accidentally overshoot it. Guess what you have to do? Dump it out, reweigh it, pour it in again, add water until you get exactly to that line.
So you waste.
So you wasted, yep. And you wasted your time. It's a pain. Okay, are we good with making a solution from a solid?
Yes.
All right, let's make a solution from a concentrated solution. So For 2, it says I have 6 molar stock solution of NaOH. I want 250 mils of 2 molar solution. So, to do this problem, because I'm diluting my 6 molar solution, I'm going to be using my formula, M1V1 equals M2V2. Okay? A lot of people are freaking out about, how do I know which ones go together? If you listen to the way that I've written this, it says I want 250 mils of 2.0. So those guys go together. So the concentration, 2.0, volume, 250. Keep in mind, I had said for this type of equation, if this is in mils, and you want this to be in mils, you can keep it in mils. You don't have to convert to liters. If you want to convert to liters, fine. I never do personally, because then I'd have to convert out of milliliters into liters and then back into milliliters for your final answer, which I think is kind of a pain. Okay, the molarity is 6 molar, so I've got to figure out what volume of that concentrated solution I need. So when I solve for V2, what do you end up getting? Okay, 83 milliliters. So unlike this problem where I found a mass, I have a volume. How do you measure volume? Not with a scale. You need to use either a volumetric flask or a graduated cylinder. So let's look at my tools that I have. I need 83 mils. I have an 1,000, a 500, a 250, a 100, a 50, and a 25 mil volumetric flask. Can I measure 83 mils in any of those? No. So I'm going to have to go to my graduated cylinders. Let's see. I have in 100 mil, 500, 50, and 10. Which graduated cylinder would I use? The 100, okay? So I'm going to measure 83 milliliters of your 6.0 molar stock solution. In a 100 mil graduated cylinder. Then you're going to add that or pour it into well, let's figure it out. I want my final volume to be 250 milliliters, just like this one. So what tool am I going to use now? The 250 volumetric flask. Pour into a 250 mil volumetric flask. And for the third and final step, add enough water to get a final volume. My hand hurts. And I'm done. Yes.
If it's a 260 milliliters, you use
I'd have to use the 500 mil graduated cylinder. Yeah.
How come we don't use like 2.0 molar in any of the steps to explain?
Because what I'm creating at the end, so I take this, right? I measure out 83 mils in my graduated cylinder of my 6 molar NaOH. Then I pour it into my 250 mil volumetric flask. I pour it in, okay? Then I add enough water to get a final volume of 250. Once I mix it, what I have in front of me is 250 mils of 2 molar solution now. Does that make sense? So in here, it was 6 molar, poured it in, added enough water to get a final volume of 250. Now it's 2 molar. And I'm done. I would put some parafilm on it, which I'll give you guys in class on Thursday. You'll mix it, and you'll have your solution be ready to go. Are we good? All right. The other class, when they took their quiz, I would say out of 24 of them, 22 or 21 of them got 100%. The people who didn't forgot to put the value, right? So they would say, oh, put it into a volumetric flask. They didn't tell me the size of the volumetric flask that was needed. So make sure to be specific about what size of each tool you need. Okay? All right. So I'm going to go through 1 through 4. Please, as I'm going through, if you guys have questions, if something doesn't make sense to you, please let me know. And I'll explain. There's only really one new one new concept here, and it's using our concentration as a conversion factor. That's the only thing that's new here. So for number 1 I'm on page 53. It says how many grams of aluminum are required to react with 35 mils of 2 molar hydrochloric acid. So I think the most challenging part of this for anyone is just knowing where to start. It's asking for grams of aluminum, so I'm obviously not going to start with aluminum. So I'm going to start with the 35 milliliters of hydrochloric acid. And the reason why I don't start with the concentration is because I'm going to use concentration as a conversion factor in just 1 second. Okay? So I want to get this out of milliliters into liters so that I can properly use it. Now, if you can do that in your head and you don't need to show the conversion, awesome. But if you can't, it's perfectly fine to write it out. So you've got milliliters, liters. 1 milliliter is 10 to the negative 3rd liters. Okay. Now, I'm in liters of HCl. And I need to get into moles of HCl so that I can get into moles of aluminum. So unit-wise, all I'm going to do, I'm going to put liters on bottom, moles of HCl up top. And if you guys look at these units, this is moles per liter, which is the same thing as saying molarity or molar. And so I know the molarity of hydrochloric acid. It's 2.0 molar. So I'm going to put 2.0 on top, 1 on bottom. That's the new thing. That is the new concept for this entire section, is just using molarity as a conversion factor. I'm now in moles of hydrochloric acid. I need to get into grams of aluminum, so I first need to get into what of aluminum? Moles. I'm going to put moles of hydrochloric acid on bottom, and I'm going to put moles of aluminum up top. Okay, mole to mole ratio is what? 2 moles of aluminum for every 6 moles of HCl. Okay, and then since it asks me to get into grams, I'll do one more step. Moles of aluminum on bottom, grams up top, grams per mole. That's a conversion factor we've looked at. That is just going to be the molar mass of aluminum, right? So 26.98? 982? Okay, sorry. All right, so when I do that, looking at all the values that are given to me, 35 mils, 2.0 molar, I want 2 sig figs, so my answer is going to be 0.63 grams. We okay with that? Questions for number 1? Okay. What if instead of giving you asking for grams, what if I said that I have I'm trying to think if I can change this problem properly. Hold on 1 sec. No, I'm going to leave that for number 1. All right, for number 2, the setup is almost identical. And I got 210 grams. Are we okay with that? All right, I'm going to show you my setup really quickly because I'm going to change the problem a tiny bit just to spark a quick conversation. So I have my volume here. I get into moles of sulfuric acid by using the concentration. Bless you. Okay. Then I'm going to use my mole. Actually, no. Really quickly, if we look at 1, I'm going to just kind of change the problem slightly. What if I told you, hey, you've got 35 mils of 2.0 molar HCl. What is the concentration, even though it doesn't make sense because aluminum is a solid, but what's the concentration of aluminum if I have 2.0 liters of aluminum? So I'm not asking for grams. I am now asking for the concentration. So what's the concentration of aluminum? So at this point, if I stop right here, I've got moles of aluminum. Does everyone agree with that? Okay. What would I need to put for a conversion factor in order to get into concentration? Which, remember, concentration is moles per liter. So I need liters on,
For every 2.
hold on. I'm in moles right now, right? I want moles per liter or moles over liters. So what would you put on the bottom? I want to stay in moles. I don't want to get rid of moles. I like my moles. Keep my moles. But I want moles. I want my unit to be, I'm asking for concentration, so I want my unit to be moles per liter, right? I'm already in moles, so leave it alone. I don't want to cancel that out. What unit should I put on bottom? Liters. Because then that'll be moles per liter. Do I need a unit on top? I'm in the units I want, right? Moles per liter. We're okay with that, right? So what could I put up top? Why not? How many liters do I have of aluminum? 2.0.
Do we have any problems with that?
Nope, that's why I'm throwing it in there. When you see it, then you won't be like, how do I do that? And then I say that and you're like, wait, hold on. So if you want your final answer to be in moles per liter because you want the concentration, remember, to find concentration, you just take moles and you divide by your volume. You divide by liters. So keep that in mind, and then when you come to it again, you won't be like totally confused and bamboozled, and you'll be able to get it. So that was 1 and 2. 3. How many liters of a 0.75 molar solution of calcium nitrate will be required to react with 148 grams of sodium carbonate? So what is my given for number 3? What do I start with? 148 grams. That is my given. Okay, so I need to go from grams of sodium carbonate. I need to get into moles of sodium carbonate using my molar mass of sodium carbonate, which I got to be 105.99. Then, in order to get into moles of calcium nitrate, I need to use my... Well, Jenilyn's doing a really good job of filling the blank, but the rest of you guys, like, D- work. All right, Jenilyn, quiet, time out. So this was 1-to-1. Now, the question asks, how many liters of calcium nitrate? So what unit would I put on bottom? Moles. What unit up top? Liters. So moles per liter, that is the concentration of calcium nitrate. Calcium concentration that I gave you was 0.75 moles per liter. So the volume that I end up getting, 1.9 liters.
Yeah.
Are we okay? All right, for 4, I got 0.015 liters. I got 0.016, but the other class freaked out and told me it was 0.015. Is that what you guys got?
Yeah.
Awesome. Okay. 5. 5 is a little bit tricky. 5 is tricky because I give you 2 different concentrations, and if you're not careful, you can mix stuff up. But for number 5, it asks how many milliliters of 0.10 molar lead nitrate are required to react with 75 mils of 0.2 molar NaI. So my given for that problem is what? Awesome, 75 milliliters. So instead of showing that conversion, because I want to save time, I got things to do, I'm going to just divide 75 by 1,000 because that will give me the volume in liters. So I'm just going to write it as 0.075 liters. Are you guys okay with that? Did I just like destroy your worlds, or are we okay? Destroyed it, but okay? All right, so that many liters of sodium iodide. Okay, I need to get into moles of sodium iodide, so I'm going to use liters on bottom, moles of sodium iodide up top, moles per liter. That is the unit for what? Molarity, thank you. So the molarity of sodium iodide that I gave you was 0.2 mole. molar, so 0.2 moles for every 1 liter. The moles mole here is 2 moles of sodium iodide for every 1 mole of lead nitrate. Last step, I want to get into liters, well actually, eventually milliliters. Second to last step, I'm going to put moles of lead nitrate on bottom, liters up top, moles per liter. This is my concentration. So I got 0.10 for every 1 liter. Last step, get out of liters, get into milliliters. 1 milliliter is 10 to the negative 3rd liters. So when I did this, my final answer, I got 75 mils. Wonderful. All right, yes. You may. So guys, Paige, can you actually fill this up for me and not spit in it? Okay. Okay. It's a little long of a pause, kind of like, okay. Page 55 and 56 is what you're going to work on right now. If you look at number 5 on page 56, I just want to make sure we're on the same page. For number 5, it says a solution is made by mixing 15 grams of calcium hydroxide and 55 mils of 0.2 molar phosphoric acid. So I've got 2 different quantities of reactant that I'm giving you. What type of problem is this? If I'm giving you the amounts of 2 different reactants. Starts with an L. Limiting, whoever said limiting reactant. Okay, thank you, Rachel. Limiting reactant. So be careful because that's 2 problems in one. It's asking how much precipitate forms. You're going to have to figure out how much each of those form individually and figure out which one's actually made. So it's kind of a lengthy, mean problem that I think is a really good problem. So work on 1 through 5. My answers are up here. You can come and check them whenever you need to.